As we go along, please fill in the worksheet handed out today in class. Starting with number 1, the clue was the multiplication distributes across addition. So in this case, it's the distributive property. Automatically that word distribute should show that. The distributive property can be of addition or of multiplication. So it shows that A times the sum B plus C is the same thing as distributing A times B plus distributing A times C. And then here we have a numerical example to copy down as well. Number 2, commute, means to get up and move to a new location to switch places. So here we have our commutative property, and again, this can be of addition or of multiplication. So in this example, A plus B is the same thing as B plus A. The order is changing. In our next example, it shows the same property but of multiplication instead. So A times B is the same thing as B times A. Number 4 is talking about regrouping elements that do not physically move, they simply group with a new friend. So grouping is talking about the associative property. Now 4 and 5 are both the associative property, but it can be the property of addition or of multiplication. So you can see here that A plus the sum B plus C is the same thing as A plus B plus C. And here again we have a numerical example, and the same goes for multiplication. A nice way to remember commutative versus associative is the acronym COAG. Commutative, the order changes. Associative, the grouping changes. So a nice shortcut to check the associative property, if you're reading left to right, it's A, B, C, and then it's still A, B, C. Whereas when we looked at the commutative property earlier, at first it was A, B, and then it was B, A, so the order is changing. So a nice shortcut to see if the commutative property is being used is to see if the numbers are still in the same order. So here it's just the parentheses moving, the numbers stay in the same order. Here the numbers are actually switching places. Moving on to number 6. Our hint was that the value that returns the input unchanged. So this is our additive identity property, and following that we're going to have our multiplicative identity property. So additive identity means that anything plus 0 is itself. So obviously 4 plus 0 is 4. But the multiplicative identity is anything times 1 is itself. So moving on a bit further, number 8 tells you the value that brings you back to the identity element under addition. Number 8 is the additive inverse property. So anything plus its additive inverse will give you 0. So 4 plus negative 4 gives you 0. So basically the opposite of any number. So if our original number was 3, the additive inverse would be negative 3 because the sum of them gives you 0. Moving down to number 9, the value that brings you back to the identity element under multiplication. So the identity element in multiplication, as we saw up here, was 1. That was the identity element. So what's going to bring us back to 1 is the multiplicative inverse. So any number times its reciprocal or its multiplicative inverse. That means the same thing here. So either multiplicative inverse, or you can say reciprocal. So here we see 4 times 1/4. The reciprocal of 3/4 would be 4/3, and 3/4 times 4/3 would give you 1, which is the identity element under multiplication. Moving on to number 10, we have the 0 property of multiplication. Anything times 0 is itself. So 4 times 0 is 0. 0 times 0 is 0. Number 11 states that the sum of any two real numbers is another real number. This is the closure property. In this case, it's of addition. Number 12 is talking about the product of any two real numbers is another real number. This is the closure property of multiplication. So basically, if you add two real numbers, your answer is going to be a real number. If you multiply two real numbers, your answer is going to be a real number. And finally, on this side of the page, we have that adding the same value to both sides of an equation will not change the truth value of that equation. This is going to be our addition property of equality. So if A equals B, then if you add A and B to two things that are equal, it will still be equal. So this is what we see when we're solving equations. In other words, if x equals 10, like in our example here, that means that since we know that 3 equals itself, then x plus 3 must be equal to 10 plus 3. So we know that 3 is equal to itself, and we're being told that x equals 10. So that means with the 3 on both sides, you can add x to this side and 10 to this side, and the two sides will still be equal. On the next side of the page, number 14 states that subtracting the same value from both sides of an equation will not change the truth value of the equation. Here we can see, similar to the addition property of equality, the subtraction property of equality. So if we have that x equals 10, and obviously again we know that 3 equals itself, then we could do x minus 3 on this side and 10 minus 3 on this side, and it will still be a true statement. Here again, we have multiplying both sides of an equation by the same value will not change the truth value of the equation. So this is our multiplication property of equality. And then finally, when we're talking about solving equations, dividing both sides of an equation by the same non-zero value, because dividing by 0 would make it undefined. We can never divide by 0. Will not change the truth value of an equation. So here we have this example. When we're talking about the substitution property, a value may be substituted for its equal. If A is equal to B, then A may be substituted for B, or conversely, meaning or the opposite. So if x equals 5, then we can substitute in 5 for x to make it 5 plus y equals z instead. A real number is always equal to itself. That it would be the reflexive or identity property of equality. So obviously we have A equals A, 12 equals 12. It's always equal to itself. This is our reflexive property of equality. Number 19 states that quantities that are equal can be read forwards or backwards. So we can either read it as A equals B or B equals A. This is the symmetric property of equality. This is going to come in handy when you want to flip equations. You can read it either way. So it doesn't matter if it's x plus 3 equals 7 or 7 equals x plus 3. The equal sign makes it almost like commutative. You can change the order, so you can flip it. Number 20 states that if two numbers are equal to the same number, then the numbers are equal to each other. This is our transitive property of equality. So if A equals B and B equals C, then A equals C. So if 2A equals 10 and 10 equals 4B, since both equations are equal to 10, then these two pieces must be equal to each other. So that's our transitive property of equality. This final property, number 21, doesn't normally come up in testing, but it's something that's kind of common sense, as you can see down here. For two real numbers, A and B, A is either equal to B, greater than B, or less than B. So there's only 3 options, which is why we're either going to be seeing equations or inequalities this year. So this last one is our law of trichotomy. So exactly one of the following has to be true. Either A is less than B, it's equal to B, or it's greater than B. So if you have two numbers like 8 and 6, 8 is greater than 6, which means that it can't be equal to 6 and it's not less than 6. So only one of these three is possible. You can't have more than one possible at the same time. If you have two numbers, it has to fit into exactly one of these categories. The last few things that I would like to add in, just at the end of your paper, and move all of this up, would be talking about opposites. If you're talking about the opposite of a sum, and if you could copy down opposite of a sum, that means that if you have a sum, a plus b, the opposite of that would be to negate it. And we know by our distributive property that that means negative a plus negative b. So if they ever ask you to take the opposite of a sum, and we know this is the same as negative a minus b, because plus a negative is the same thing as minus. That would be the opposite of a sum, or you could even say the opposite of a difference would then be negative a, and then distributing a negative to a negative would mean plus b. Opposite of a product would then just mean that product, it's distributed to one of them. It's not being distributed to both of them. So that means the product is negative, which means either of those factors of the product are negative, either the A or the B. And finally, and this is a lot of the times forgotten about, when you're talking about the opposite of an opposite, let's say we have a negative A, the opposite of an opposite, the opposite of a negative would then make it positive. So if I asked you for the opposite of negative 3, that would mean negate it again, and that would make it positive. If I asked you for the opposite of positive 3, that would be negative 3. But when you negate a negative, they sort of cancel out, because a negative times a negative is a positive, and that gives you your final positive answer.